So we're going to find the derivative of x to the x. Now, I don't know about you, but when I was in my calculus class, they never told me how to differentiate a function to a function power. So we're going to have to figure out some other way to deal with this. And to do that, one idea is with implicit differentiation. So let's take this function and say, let's y equal to x to the x. And what we can do is if we take the natural log on both sides here, the natural log of y is equal to, and then if we do the natural log of x to the x, well, the natural log of something to a power, we can bring that power to the outside and have it multiplied. So this is equal to the natural log of x to the x, but we can take this x out, put it in the front right here. So we just have the natural log of y is equal to x times the natural log of x. And now we have things that we know how to differentiate. So let's take the derivative with respect to x of everything here and use implicit differentiation. On the left side, the natural log of y, if we take the derivative of the natural log will get 1 over y, and then we have the derivative of the inside by the chain rule will just be y prime, and then on this side we have x times natural log of x, so we'll use the product rule. The derivative of x is just 1, so we have 1 times natural log of x, and then the derivative of natural log of x is 1 over x. So we have plus 1 over x times x. So again, 1 over y times y prime equals natural log of x, and then 1 over x times x is just 1. And now we want to get y prime because that's the derivative of x to the x, so we can multiply by y on both sides. We get y prime is equal to, if we bring this y up here, we're going to get y times natural log of x plus 1. But we know y is equal to x to the x. So we can write this y here, bring it over here, x to the x times natural log of x plus 1. That right here, this is the derivative of x to the x.